able to. Usually that's not the problem. Usually errors come on their own, even if you don't try. But I made, I pulled an old example that I had, and I made a new example to try to illustrate exceptions a little bit better. Let's review. An exception is, you could think of it analogous to an error. Or one of the sites I read talked about it as an exceptional circumstance. So, maybe not an error per se, but something that is out of the ordinary that you might want to address. And you can address it in a number of different ways. But typically we think of these things as errors. Now, there are different kinds of exceptions. The basic strategy with exceptions is you put a block of code that you think is vulnerable to exceptions in a try-catch block. The code is tried, and then you catch the possible exceptions. That is, the errors that could occur from within that block of code. And there's any number of different errors that could appear. The hierarchy for the exception class is something like this. You have an exception class which inherits from something, I think, throwable. Inheriting from that are runtime exceptions. And inheriting from that also is a whole bunch of other exceptions. From runtime exceptions, there can be also inheriting a whole bunch of exceptions. What are the difference between exceptions, things that inherit from exceptions, and things that inherit from runtime exception? All right. In other words, what are the difference between these exceptions and these exceptions? All right. I believe these two are abstract classes. Typically, yeah, you don't get an exception. You get a specific kind of exception. So the exceptions that you're likely to catch will be one of these or one of these. What are the differences between these? Things in this group are called checked exceptions. Things in this group are called unchecked exceptions. Okay? Interesting. What does that mean? A checked exception is something that you have to handle in your code or pass it on. Otherwise, you get a compiled error. All right? So, a lot of the exceptions we're going to make are going to be checked exceptions. That is, if a particular piece of code throws that exception, whoever called that piece of code, whoever called that method, either has to deal with it or pass it up to the next guy in the chain. All right? If you have a case of function A calling function B, calling function C, calling function D, if D throws a checked exception, then C either has to handle it, all right, or in turn throw it. And who's it going to throw it to? It's going to throw it back up the ladder, back up to B, back up the ladder to A. So someone has to handle it or throw it. That's the two rules for a checked exception. In other words, you have to take care of it if it's a checked exception. Otherwise, you get a compile error. All right? An unchecked exception is an exception that you can catch if you want, and you can handle it if you want, but you don't have that requirement of either catching it or throwing it up the chain to the next guy. All right? And they talked about the difference between the two. They said that a checked exception, you should throw checked exceptions if you think that the client has a reasonable chance to recover from it. All right? For example, we might have a GUI that allows us to create an automobile class, and we might try to set its miles per gallon to 200 miles per gallon. Well, we might have code in our automobile class say, wait a minute, 200 miles a gallon, that doesn't exist. I'm going to throw an exception. Well, that's something that the client can reasonably handle, right? The client can then simply prompt with an error message and say, well, look, that's out of the valid range of proper miles per gallon. Please enter something else. So that's an example of something that it can handle. Other sorts of exceptions, and what they say in what they said in some of the research from Oracle's site is that unchecked exceptions are by and large the results of like programmer sloppiness. Like you are casting something incorrectly, or you are allowing for dividing by 0 or something like that. And in which case there's really not much whoever's using that class or method can do about it. So again, we'll most of our examples, because we're going to focus on throwing them and catching them, will be on the checked exceptions. But there is a whole another group of exceptions as well. All right, here's the example I put together, the first example I put together to show catching multiple exceptions. So I have I put it somewhere else. Okay, I just have a class called execjava. I'm going to open it up and look at it in Notepad. And we'll look at what it's going to do, and we'll look at the different kinds of exceptions that this person, I've been working on computers too long. I did make a point to get outside today, and hopefully I need to continue doing that. What I did is I made an array list. This also shows a little bit of what is called boxing. All right, boxing and unboxing. We'll talk about that in a minute here. So I made an array list, and I created an int, and I created an integer. All right, what's the difference between an integer and an int? An integer is a class, an int is a primitive. An integer is often called like a wrapper class. In other words, it's sort of the object version of an int. All right? Why do you need an object version of an int? Well, you can't put primitives on an array list. All right? That's one reason. But you can put integers on an array list because an integer is an object. All right? So the boxing part comes in like this. I made an integer called I made an int called I made an integer called I set I to 3, I set the primitive to 3, then I simply said I equals I. All right? That's what's known as boxing. It allows us to more seamlessly convert an int to an integer. All right? In other words, you can more or less treat an integer object like it's just a plain old integer primitive. All right? And that's what's known as boxing. And unboxing is, or boxing is where you take an int and make it an integer. Unboxing is where you take an integer and make it act like an int. All right? So in this case, we're taking an int and we're putting it into an integer. So that's boxing it. All right? So now we can go and we can put that guy on our array list. So I have a statement that adds it to my array list of C. Then I'm looping through the array list. All right? And I'm grabbing each element off that array list in turn. All right? I'm casting it as an integer. And then I'm squaring the integer. So I've unboxed it. All right? And I'm outputting the value of the thing squared. So there's no errors in that. The errors come in here. All right? And we'll talk about the errors. But I want to make sure we understand the basic code of how that works first. So let's go compile it and run it. All right. All right. I put 3 on there. I squared it. I get a value of 9. So that's a normal, what you'd expect. Now, what's going to happen when I do this? I'm adding a second element to my array list, an element that is S, which is a string. What's going to blow up and why in this example? When I try to cast a string as an integer, right? I can go and I can add that S to my array list. That's fine. Because an array list, unless I specify specifically the kind of object I'm going to put in it, an array list I can put any object in. So I can put an integer and I can put a string and I can put any old object I want. That's fine. However, when I loop through this and cast it as an integer, that's where the problem is going to start, because it's going to try to take that string, string object that's on the array list and cast it as an integer, which it obviously can't do, and it will blow up. That's actually why I got that warning saying I was doing something dangerous. All right, because it sort of knew, hey, how does this guy know that there's only going to be integers on there? I don't, and therefore it's dangerous. All right. So we're going to run this, and we are going to then see what we get. So let me go and compile it. All right. Exception in the main thread, Java lang Classcastexception. And I'm going to write that down. This must be what kind of an error? What kind of exception? It must be a runtime, right? Why? Because the compiler didn't complain about us that we didn't catch it. All right? It warned you. Yeah, that's true. That's true. The instant those words came out of my mouth, I realized, yeah, it kind of did complain a little bit, but it didn't complain hard enough, as opposed to giving you a compile error. All right, so that's the one kind of error that we can get. All right. I'll comment that line out. And I'll look at this. See add null. Well, what's that going to do? Well, we're going to get our null object reference. Because we've added an integer to it, then we're adding a null object to it, and therefore first time through it's gonna it's going to work. Second time it's not going to, or when it hits that element it's not going to know what to do with it. So let's go and compile this. All right, and we run it. Null pointer exception. That's the kind of thing that we had last time. Now, just for good measure, I'm going to go in and I'm going to create a third exception. See? This annoyed me last time, so I went back. It's like, we're going to crank out a lot of exceptions this time. And I'm going to repeat this and loop this through one extra iteration. All right? In other words, in this case, there's only one element in our array list. So j should just be 0, and the loop should then terminate. But I'm going to try to do it one more time. All right, and we'll see what happens. I'm going to get some sort of error, right? I'm not going to get compile error because it doesn't know at this point. But I will get a runtime error. And I get an index out of bounds exception. Because there is no element 1 in that array. All right, so we have 3 different exceptions. All right. Right now, we're not catching any of them. All right. What I can do is I'm going to wrap this in a try-catch block. And first, I'm just going to catch an exception. All right. I'm just going to catch exception. All 3 of these are runtime exceptions, as it turns out. But I'm going to catch exception. All right. And we'll see how this works. So let's go here and say try catch, and I'm going to go Google this real quick because I think there's parentheses around there, but you should have went with my instinct. Catch. And I'm going to say exception E. Whoops. E. And right now, I'm just going to display a message that is a message of my own writing. In other words, I'm not getting the ugly system error. I'm gonna explain it hopefully in understandable terms. All right. So I'm just going to display out a message that says the exception has occurred. So I'll go and I'll run this. And right now, what is the exception we should get? We should get the index out of bounds exception. So let's go and we get an error saying exception has occurred. All right. So we didn't get the ugly message that no one could understand, but we got a more readable, more understandable message. All right? Now, problem is, all right, problem is that if I told you to close your eyes and I went and generated another exception, a different kind of exception, guess what? You're not going to have any idea what specific exception occurred. All right? Why? Because this block of code is catching every exception that happens. So it doesn't matter what exception this block of code generates, this is catching it. All right? Now, how do I know it's catching every exception? Because I said I want to catch every exception that is created. Now, what's the significance of E? I say I want to catch any kind of exception, and then I have an E after it. What is E? It's not a type. It's a variable. All right. It is an object, and it is an object of type exception. Now, we could do a little better than this, right? Because we have an object called E, which is an exception object. Let's see what's available in the exception object. All right. in terms of what there is. All right? Because maybe we can print out a more descriptive error message than just saying an exception has occurred. Maybe we could print out a message saying, like, specifically what kind of problem has happened. So let's go and let's look at the exception class in Java. And there are several of them. There is a print stack trace. We'll play around with some of these. All right. Get cause, get localized message, get message, toString. Let's try get message, and let's see what that does. That looks like it's going to give us some sort of error message, right? So I can say, can add to my end of my message e.getMessage. So essentially the idea is this. If an error occurs, any kind of exception, information about that exception is put in an object called E, which is of type exception. And we can then go and we can access the properties and methods of that exception object to give us maybe a little more information about it. All right, let's try this now. And I forgot to save it and compile it. All right. So, notice what it says now. Squared exception has occurred, and we give some additional information from it. That's in the that came as part of the exception object. We could try some of these other things. Let's see what get cause gives us. Now keep in mind, this is something where we might have a couple different modes. In other words, when we're debugging our code, all right, we may be displaying some of these gruesome looking error messages, and then we go and change that, before we actually deploy it, all right, when it's finalized. That definitely is something that can be done. All right, that particular attribute is null for this kind of exception. Let's do a get stack trace. Or let's do a toString, and let's see what the toString does. A lot of objects or classes have a toString method, which sort of makes a string version of them. All right, and it's effectively the same thing. A little bit, I think, more verbiage in there. Let's do one more. Get stack trace. Okay, that doesn't seem to be terribly meaningful to us. There might be more involved in using that. All right, the bottom line is this. When an error occurs, when an exception occurs, we can check to see if an exception occurs, and we can deal with it some way, and we can get some information about the error and do something with it. Now, in this very simplistic case, all I'm doing is I'm displaying on the console. All right? But you could imagine a lot of other sorts of things that could happen. All right? We may write to a file if there's an error. Right? We might write to some sort of log file. We might identify it as a, errors based on their severity. A critical error, a warning sort of exception, and so on down the line. So, we may not always want to deal with exceptions always in the same way. In this case, all I'm doing is outputting to the screen, so it may be hard to envision. But in other sorts of applications, we may want to do something a little bit different. All right? And that's where we can trap for specific kinds of exceptions. So what I could do is I could do this. Catch exception class cast exception, and I can output handle this one differently, knowing that that's just a placeholder for actually handling it differently and doing something different for it. All right, let's go and compile this and see. Classcastexception, yeah, we should. This is the one that we should be getting. So let's save this. Oh, yeah, my mistake. Oops. There's nothing magical about the fact that I call that E, by the way. I could call it EXE. Now, the reason I can have two things called E is because these only have the scope of that catch block. So this E is different than this E. All right? All right, at any rate, I go and, oops, I already did that. Compile it and run it. And now I know that I have this one is handled differently. All right? So I know that I've told specifically that this is that kind of exception, so I'm going to deal with it in a little bit different manner. Now, what if it is one of the other kinds of exceptions? So let's go and let's comment this guy out and uncomment this guy out. Go compile it again. Run it. All I know is that an exception has occurred. Does that make sense to you? This time I should have got a null pointer exception. Well, I ran this code. I got a null pointer exception. All right. It's not a class cast exception, so it didn't do this code. But it is an exception, so I can run this code. All right. If I didn't have this in here, then I'm not handling that kind of exception. And therefore, the runtime will give me its exception error as opposed to the nice user-friendly message that I had. So the idea here is I could go and I could do different things depending on the specific exception that occurs. All right. Keep in mind, in this case, I'm dealing with the built-in runtime expression. So the kind of errors that are getting are kind of goofy, right? Null object, array out of bounds, and so on. But one thing we can do is we can extend Java's framework and add some of our own exceptions there. Then our application might have a fighting chance of being able to do something a little more meaningful for those. All right. There's one more clause on the try-catch, and that is a finally. And the finally occurs regardless of whether there's any exceptions or not. All right? So even if there are no exceptions, the finally block will occur. What they mentioned is that's a good place for you to put like cleanup code. Maybe you open a file or something and when you're all done, hey, go and close that file. That way, no matter where it blew up, let's say that this involves writing to a sequential file. All right? Maybe we open the file here, we do a bunch of operations, any one of which could blow up. Well, when we're done, we want to close that file, right? And if it works, we want to close that file. So this is a place to put sort of nice little, for this block of code, nice little terminating activities. So this will run, again, regardless of whether there was an error or not. Let me go and comment that out so that there's no error. Yeah, because I'm looping through it twice. Right? My try-catch is itself within a for loop that loops through. So if it does that for each element in the array list. All right. Now here's one thing I want to try. Does it matter the order of these things? I'm thinking it does. In other words, if I put the generic exception before the specific exception, which is it going to call? And I think it's going to call the generic one. But, or both. Probably not neither. Gives me a compile error. Yeah, very good. In other words, it knows that this exception caught this guy, so therefore it knows that that code is bogus, right? Because why catch it again, all right? So therefore, the compiler does you a solid and catches that potential issue. All right. Okay. Yeah, I don't know. Let's see. No, it does tell you a line 27. Oh. Yeah, exception. Yeah, I mean, Java is sort of developed by, really hardcore programming types, so it's no wonder that the error messages aren't necessarily always the most descriptive. All right. Okay, now, that deals with these exceptions, and the try-catch structure is going to be the same, but now we're going to talk about our own exceptions. All right? Our own exceptions of, that we can set certain properties for. All right? So, let's look at the other example I have. All right, I'll make sure to upload the changes. That one. I'm kind of thinking out loud, I know. All right, let's look in these. And I'll tell you what. I am going to delete all my class files. All right. Now let's look at these classes. And we probably should get through most of this today. If not, we'll get through a a good part of it, and we can wrap it up on Monday. All right. I have a class that identifies whether someone is eligible to get their driver's permit or something. This is their temporary permit. Or not, I don't know. I guess I made it up so it can be anything you want it to be. Probably made this up when my first kid was going to get her driver's license, so it was on my mind. It's amazing to go back over time at the examples I have and know what was going on in my life, because it's like, okay, that carpet example, yeah, that's when we're getting new carpet. And so anyhow, so I have a method that says is eligible, that looks at, and you give it the age of the driver, you give it the I-test score, whether they passed or failed, and you give them the numeric score that they got on the test from 0 through 100. Now, few things to remember, right? There could be a few different issues with this. Number one, we could give an invalid age to this function. All right? A negative number is not a valid age, right? Maybe there's a maximum age that we could put in, that no human has ever lived to. All right? Likewise, we know that the score, it has to be between 0 and 100. All right? A negative score or a 110 is not valid. Now, those invalid conditions are different than someone merely not being eligible for a driver's permit, right? Those are different things. So really, in a way, that sort of expands the signature of this method, all right? To have the return value of a Boolean that says, yes, this person is eligible, no, this person is not eligible, or to throw an exception. So really, two different outcomes could happen to this. It could return a Boolean that says, yes, the person's eligible, no, the person is not eligible, or it could throw an exception. And I believe, let me go and look to confirm that. I extended these, my exception objects, I extended them from the exception object. That means that these are checked exceptions. So, anywhere where these exceptions occur, I either have to have a try-catch block there to handle them, or I have to throw them up to whoever called this. All right? And I can throw it up several different layers till someone handles it, but someone has to handle it, the bottom line is. It's a checked exception. The compiler will check to make sure that someone is taking care of business here. All right. So, first thing you notice, again, is this function could return a Boolean, or it could throw one of three different kinds of exceptions. The three different kinds of exceptions are, correct myself, two different kinds of exceptions. All right? There could be a problem with the age, or there could be an issue with the score. All right? If you think about it, there's a lot of times where we want to return a value, and we also want to return some kind of status that indicates whether the operation worked or not. All right? An exception is a way to do that, because remember, a function can only return one of something. So if we try to do a conversion of something, we could return the converted answer, but if an error occurs in that conversion, how do we do that and return an answer? Well, we can't. So the exception is a way that, hey, we can throw an error code if there's a problem, or we can return a legit value if it's okay. All right, so let's look at this. What I have is, and let me go and draw the diagram for this. So I don't know if I used all these classes in this example or not, but I have a driver's permit exception that inherits from exception. So therefore, this is a checked exception. All right? And I'm doing some constructor chaining here. All right? Doing some constructor chaining here. If I create this exception, it calls the superclass's constructor and passes it an argument. We'll see how we're using that argument in a bit here. That allows us to give a message to the exception, because the argument in the constructor of the exception is a detail message. So we're allowed then to pass that message from the child up to the superclass. All right. Now, we then have a couple things that hang off of that one. We have a driver's permit age exception that we essentially do the same thing. And we have a driver's permit low exception where we essentially do the same thing. All right? That would allow us to put in different levels. So we could, you know, if we decided on a maximum limit for the age, right, we could have a driver's age low and a driver's age high. And we could either choose to throw the individual exceptions or just throw the fact that there was a problem with the age. All right? And, or when we go and write our catch. We could catch each specific thing if there was a different thing we wanted to do if the age was too low versus the age was too high. Or we could just catch driver's age exceptions and handle both too high and too low the same way. I then have a driver's permit score exception, which again just calls the superclass. So nothing exciting there. Now, in my method to determine if the person is eligible, I define my return value. I have a series of tests, actually 2 tests, that look to see if either of those 2 error conditions occur. So, if the arg age is less than 0, then I'm throwing a driver permit age low exception. And I'm making my message include the value of the age along with some text saying is too low. All right? I then have a score, and if the score of the test is greater than 100, I guess I'm allowing negative scores, right, in case someone gets their name wrong or something and they actually get docked a couple of points. All right? I'm throwing a new driver's permit score exception, and again, I'm passing the score as part of the constructor, so it will be there in the message. All right? Now, you might say to yourself, all right, isn't whoever going to call this have their own validation and make sure that we don't put in a negative number for age? Well, you don't know that, right? The whole idea here is you're building a component. You're building a component that other people can take and plug into where they need to do this sort of processing. So you would hope that their user interface or whatever they did had some sort of validation to keep that from happening. But, all right, you want to build your component to be foolproof and rock solid. So therefore, you can control the, you can control that you send them a double, right? So you know that they're not going to send something goofy like a string there, right? Because otherwise they get a compile error, all right? So you know they're going to send a double, but you can't, through the compiler, enforce that double is positive. You can only go and test test it in your method and throw an exception otherwise. Finally then, if none of those two exceptions happen, then this goes to completion. If they pass their eye test and their age is greater than or equal to 15 and a half, which means this is the learner's permit, all right, and their score was over 75, I'm going to set the value to true, otherwise I set it to false, and then finally I return that. All right. Let's then look at the test case. Yes?
Whenever you do a throw,
Mm-hmm.
does it automatically return at that point? Or
Yes.
it doesn't keep going?
Doesn't keep going, no. Throwing, that's another way of leaving this function. Right? It does not go on and continue. All right. Let's look at our test code and see what we have. I'm creating one of these. I'm asking if it's eligible, and I'm saying the age is negative 16. All right. They pass their eye test, and their score was 178. So actually, there's two potential exceptions. The sequencing of the code is going to throw the one before the other one now. All right. I have that wrapped in a try catch block. If this is valid, it will then say they're eligible or not eligible. Otherwise, it'll catch the exceptions. So the way I have this coded now is it's going to catch a driver's permit age exception. It could be a too low or too high. Remember, I have actually another level in there. But it's going to say, I know that there's an age exception. Otherwise, it simply knows that there's some exception that got fired off in there. All right? Let's run this through, and we'll run a couple tests and see how it works. And then I want to do a compile or two with this. And as predicted, I know that there's a driver's permit age exception. Could have been too low or too high, even though I don't think I have the too high class in here, but we can pretend there was. And again, the message says negative 16 is too low to be a valid age. All right. If I give a valid age, and compile this, all I know is that there's an exception, right? Why? Because I'm not testing for specific exceptions. I'm testing just for an exception. I know it's not actually, I lied. I know it's not a driver's permit age exception. I don't know what kind of exception it is. All right? Last compile, and we'll go over this again on Monday. All right? But what if this driver permit doesn't specify that it throws that exception? Well, the compiler is going to complain because for a couple reasons. First of all, it's complaining because I'm catching something that function never throws. All right? What if I remove that then? It will give me a different kind of compile error because this function throws a driver's permit age low exception, but it doesn't either catch it or say that it's going to throw it. All right, and that can't go. All right, we'll go over this sort of thing next time with the custom exceptions, and and we'll review it a bit more. All right. I'm not going to upload this because I don't think I changed it. The only changes I think I made to this one were destructive changes. I will upload the first example, though, because I did add some stuff in there. I added the try-catch block in that. So I will upload that one. All right. We'll see you up in lab.